Welcome to our presentation on high-fidelity diffusion face swapping with ID-constrained facial conditioning, accepted at CVPR 2026. This work addresses fundamental challenges in diffusion-based face swapping and proposes novel solutions that advance the state of. We will cover four main sections today. First, we discuss the motivation behind our work. Then, we present our decoupled condition injection method. Next, we explain our three-stage progressive training strategy. Finally, we showcase compelling experimental results. Face swapping aims to transfer source identity onto a target face while preserving target attributes such as pose, expression, and lighting. Diffusion models, despite their superior generation quality, suffer from a problem called condition completion. This means only identity conditions are provided. The model spontaneously generates attribute information from its pre-trained knowledge. This inherent property leads to identity attribute imbalance and suboptimal training convergence. To address this, we propose a decoupled condition injection pipeline with two fully independent branches. The identity encoder combines ARC face recognition features with DNOV, two visual embeddings, for richer identity representation. The attribute encoder leverages SimSwap's 3D-sampling network to extract expression features. A lightweight attention fusion layer then combines both conditions before injecting them into the diffusion UNet through cross-attention adapters. Our training strategy follows a three-stage progressive design. In Stage 1, we train with identity conditions only, using attribute dropout and identity classifier-free guidance. In Stage 2, we introduce joint identity attribute injection with identity loss gradient clipping and expression distillation to preserve the learned identity while incorporating attributes. Stage 3 treats the full DDIM sampling pipeline as a cascaded end-to-end model, applying combined GAN and identity losses on randomly sampled steps for memory-efficient refinement. Qualitative evaluation on FFHQ demonstrates that our method achieves superior identity preservation and attribute consistency compared to all baselines. Against GAN-based methods like SimSwap, E4S, and InfoSwap, our diffusion-based approach produces fewer artifacts and more natural skin texture. Compared to prior diffusion methods, including DiffSwap, Deface, and Reface, our results show better attribute alignment and identity. Quantitatively, our method achieves an FAID score of 3.61. Substantially outperforming the previous best result of 5.62 from Reface. Our ID top 1 accuracy reaches 97.90%, demonstrating the strongest identity in human evaluation with 1,000 votes on stylized images. Participants preferred our method 57.1% of the time for fidelity and 33.2% for attribute matching, both ranking. The progressive training design shows clear qualitative improvement across stages. Stage 1 establishes reasonable identity preservation but produces relatively flat lighting. Stage 2 adds attribute details, achieves better face shape adjustment, and improves lighting matching. Stage 3 significantly enhances identity fidelity with fine-grained details and achieves the best overall generation quality. In conclusion, our work makes three key contributions. First, decoupled identity attribute conditioning effectively solves the condition completion problem inherent in diffusion models. Second, our ID-constrained training scheme achieves better identity attribute balance through gradient clipping and distillation. Third, the decoupled conditioning principle generalizes beyond face swapping to other conditional generation tasks, requiring fine-grained multifactor. Thank you for your attention. We would be happy to take any questions.